A triangle has side lengths A equals 12 and B equals 31, and angle A equals 20 degrees. In this angle, we have opposite this side, and we have these two sides adjacent. So this is the ambiguous case for the law of sines, side angle. We'll start with this quick sketch. So we have an angle of 20 degrees, which is fairly small. The side length B, which is 31, and this side length A, which is opposite the angle A, 12. Now, it's not quite clear drawing it like, is it going to touch, or is it going to just barely? Is it not going to touch at all? Is it going to just barely touch? Will it maybe touch because it's long enough? We're not quite sure. So here's what we're going to do. I'm just going to leave it. I don't really know. Okay. But we're going to start with the law of sines. Now this side length B and this side length A, we can find the angle B. So, or we can try in the law of sines. So sine of the angle A, 20 degrees, over the side length A, 12, equals sine of the angle B over the side length B. And I'm going to go ahead and solve this as if this is going to work out, and then we'll see. So we multiply both sides by 31. 31 sine of 20 degrees over 12 equals sine of B. And then to get B, we do the arc sine. Okay, so we inverse sine of 31 sine of 20 degrees over 12 will equal B. Now, we can type this into the calculator. We're using degrees, and we're in degree mode. We have the inverse sine of 31 sine of 20 over 12. And we go ahead and see what happens. And we get a number. That's great. We get 62, about 62.1. Okay, so the angle B, about 62.1. Now, notice that we know that it connects, all right? And it connects down at this angle, 62.1. And that is, let me go ahead and redraw that now. So we know it connects down. But of course, the inverse sine function will only give us an acute angle. But in this case, when the angle A is acute, if this connects down, there's a possibility of two triangles. And that possibility arises when the side length A is shorter than the side length B, because it could connect down to the right, or it could connect down to the left. So we actually get two possibilities here. Now I'm going to go, I've found the angle B for the acute angle. That's this one right here. Okay, that's our 62.1 degrees. And now I can continue and solve that triangle if that angle is 62.1. So I'm going to go ahead and say this is the first triangle. Okay, first triangle. And I've found that angle B. So I've got my angle B equals the 62.1 degrees. And now I've got two angles, so I can find my third angle, C, by doing 180 degrees minus the two angles that I have, 20 degrees and 62.1 degrees. And this gives me, 97.9 degrees, if I did that right. I've got now all my angles, and the last thing I need is my side length C. And so I'm going to use my law of sines, 12 over the sine of the angle A, 20 degrees, equals the side length C over the sine of the angle C, 97.9 degrees. And so to get that side length C, we multiply by the sine of 97.9 degrees. Now that is a rounded angle, so when I type this into my calculator, I'm actually going to make sure that I'm not using something that's rounded. So I need my angle C, and my angle C was 180 minus 20 minus that angle B that I got up there. So I'm going to go up and hit that. So it's exact, and I'm going to store this in a variable. I'm going to store it in the variable C. Okay, hit enter. And now I'm going to go ahead and type that. That's my angle, that 97.9 spot. So I've got 12 times the sine of that angle C, and then divided by the sine of the 20 degrees. Sine of 20. And that's my side length. C, I'll round that to 1 decimal place, so about 34.8. And now I've solved that first triangle. I've got all 3 angles, A, B, and C, and then my 3 sides, A, B, and C. But that's the first triangle. What about the second triangle? What if this side length A actually connects down to the left instead? Then I want to find this angle here. And what's really nice is I know that that angle, that 62.1 degrees, I can see the way that it connects down, this middle little triangle here that isn't actually a triangle I care about, but that's an isosceles triangle. So this is 62.1 on the left as well, which means this second possibility for this angle B is going to be the supplement of the 62.1. So I'm going to do some subscripts here. I'm going to do a subscript of 1 for the first triangle on all of these, just so that I can keep track of that. And then I can find my second angle, B2. And that's going to be the supplement of this 62.1. Now I'm going to go back to my calculator for that. And actually, I guess I don't need to quite do that. So I've got 180 minus the 62.1 degrees. And I will type that in. 180 minus the 62.1. And we got 117.9 degrees. Now that is rounded. So if you want to be very precise, you can come back and subtract that value there. Okay. Now the rounded form that I've written is still the same, but now I can use that. And that is that's my angle B. In fact, if you want, you can even hit that, and let's just store that in the angle B. All right, now that I have the angle B, I can get the angle C. Okay, for my second triangle. Well, that's 180 minus the 2 angles that I had. The angle A was 20 degrees. And then minus that angle B, 117.9 degrees. And so 180 minus 20 minus that angle B. And let's do a control enter. We get about 42.1. 42.1 degrees. Now I've got my angles, and all I need left is my last side. My last side, C2. Okay, so I'm going to use the law of sines. That over the sine of that C2 angle, 42.1 degrees, equals the side length A was 12 over the sine of the angle A, which was 20 degrees. And so for my C2 side, I get 12 times the sine of that 42.1 degrees, and over the sine of 20 degrees. And so I can type that into my calculator now. I've got 12 sine of, and then go ahead and just use that thing that I just did, and then over the sine of the 20. And that gives me my side length, rounded to 1 decimal place, is about 23.5. And so we have, those are our 2 possible triangles. This is the one case where that side length A is shorter than B, but long enough to touch down. we get two possible triangles. And so it is actually very ambiguous of which one it would be. It would, of course, depend on if you could get any other information about the situation.